Okay, in this lesson we're going to have a look at a bit of problem solving using trigonometry. I'm going to assume that we're quite happy now with working out a right angle triangle, labelling sides, using SOHCAHTOA if necessary to choose the correct ratio, and to work out a side or an angle. We've been working on that. But as you know in mathematics, we learn these skills, but then we have to apply them into sometimes more complex problems. And one of the things we sometimes have to do when we're solving problems is actually just to split a problem up into steps or bits, and that might mean as far as diagrams or problems that we might have to use just a part of a diagram or split them up into bits in order to identify the thing that we're trying to find. So here's an example. We've got a situation here where it looks like we've got a big right angled triangle with and then another line coming down which is making another right angled triangle. So we've actually got two right angled triangles, a smaller one to the left and then the whole larger one. And it also makes a third triangle. And what we're actually trying to do is to work out the length of BC. So if we have a look at what BC is, if I were to take that, BC is this line here, isn't it? BC is this line here. And it's actually it's the base of this triangle here. It goes like that. So that's not a right angle triangle, that's a scalene triangle. All the sides are different lengths. We don't have a rule like trigonometry for triangles like that. We have to have a different approach to it. So the first thing I'm going to do is I'm going to give BC a letter name like X, just so that we don't have to call it BC. And the second thing is to try now and work out what we're going to do. So we want to work out the length of X. I'll just get rid of these lines there. We want to work out the length of this line. Now, notice that we've got right angled triangles, and what I'm going to do is I'm actually going to take this left hand as though I could take it out of the situation. I'm going to move this left hand triangle away. And you sometimes got to visualize that kind of situation. See what I've just done? I'll put it back in. So there, the line A to C creates a right angled triangle to the left. And if I were to redraw that like that, then what would happen here is that that's 4.5 meters. I'm going to put it over here because I haven't got a lot of space here. This is 4.5 meters up here. And 62 degrees. Now I could work out using trigonometry either of those two sides if that's of any use to me. Well, I think it is of use to me because what we can do is then work out the length of the base from D to C, and it's probably going to help me. So I'm going to call this side here, I'm going to call it P. Okay, I'm going to call it P. And using my trigonometry, I can say here that's the hypotenuse. There's the opposite, and here's the adjacent. I'm going to use SOHCAHTOA. SOHCAHTOA. What have I got then? I've got sides on the. I've got the opposite side and the adjacent side. I've got a number here and a letter here, opposite and adjacent. So I want to tick O for opposite. I want to tick A for adjacent, and I've got two ticks on TOA. That tells me that I'm going to use the tan ratio. Tan X equals O and then A, so it's opposite over adjacent. I can fill out all the information. X is an angle. Opposite is 4.5 and the adjacent is P. Okay, multiply both sides by the number on the bottom of the fraction, which in this case is P, and we've got P times tan 62 degrees is equal to 4.5, and then we've got one more step. We want to divide through by tan 62 on both sides, so they'll cancel out, and I've got P is equal to 4.5 divided by the tan at 62. So P is equal to, take my calculator, I don't know why I've made that 6.2, that was a bit remiss. Oh, okay. 4.5 divided by the tan of 62 degrees. 4.5 divided by the tan of 62 degrees, 2.392, 2.392, 2.392. Round that to say, what we do, 1 decimal place, 2.4 meters. Okay, so that's us got this information here. Now I'm going to put that back in just for a minute. See if I did that. Then what I've worked out is that this distance here, DC, is 2.4 meters. So now, if I can't still work out x, but see if I knew how long the whole base of the triangle was from D to B, if that was like 6 meters, then I'd be able to work out x, because it would be 6 minus 2.4. So the next thing I want to work out is, can I work out the whole base of the triangle from D to B? Well, I can, because if you have a look now, if I remove that, I've got this whole big triangle here. Okay, so what I'm going to do is just, well, I could redraw it. I'm just going to use the triangle that's here. I can basically say opposite the right angle is the hypotenuse, opposite 30 is opposite, and this side here is the adjacent. Okay, that's the whole side. So again, I can go, I'm going to go do it over here. So, and I've got information on the opposite and the adjacent side, opposite and adjacent side. Opposite and adjacent, again, it's T for tan. Okay, so this time I'm doing tan x equals opposite over adjacent. And what is it I'm trying to work out? I'm trying to work out the adjacent side here. Okay, so I'm going to call that a different letter. I called that P, so I'm going to call this Q. Okay, at the moment we don't quite know what x is. We know that x and 2.4 meters make something, but we'll call it Q. So I'm going to say that the tan of 30 degrees is equal to 4.5 divided by Q. We're going to do this just like we did with the last one. We're going to multiply through by Q. So they cancel out. So I've got Q times the tan of 30 is 4.5. Want to divide through by the tan of 30. And they cancel out, and we're left with Q is equal to 4.5 divided by the tan of 30. 4.5 divided by tan 30 on my calculator, 7.794. 7.794, which rounds to 7.8 meters to 1 decimal place. Okay, so we've worked out that the whole base is 7.8 meters. We know that the first part from D to C is 2.4, so there's only a little bit of working out required. Okay, so what we would need to do, I'll just try and move this up a little bit. Oops. So move it up, bring that down, get rid of that. So what we can say is that x is going to be the total distance, subtract 2.4, so we can finish that off by saying something like x, or it's like, let's just use BC. We're asked to calculate BC, so let's just use BC is equal to effectively Q minus P, isn't it? It's going to be 7.8 meters, subtract 2.4 meters, so BC is going to be 5.4 meters long. Okay, so that didn't look like something we could have done in the first instance, because remember we had a diagram that asked us to find the side that wasn't part of a right angled triangle. But if you were to redraw the diagram with the two right angled triangles separate, then you're going to be able to work out bits which will help towards it. And that's the logic, the problem solving part that you need to kind of bring up yourself. But it takes a bit of time and practice. So there's one strategy. Let's have a look at example number 2. Calculate the size of the angle marked X. Here's the angle marked X, and we've got some various bits and pieces. Now you can see that, hopefully you know now that in trigonometry we need information about two sides to work out an angle, or if we're working out a side, we need a side and an angle. So this kind of, it works around groups of three. If we need to work out one thing, we need two other bits of information. If you have a look at this triangle on the left where we're trying to work out x, okay, so let's have a look at x first of all. This triangle here, okay. Now we've got x, so we don't know x, which means we must know two other bits of information, which in this case have to be sides. We know 8 centimeters, but we don't know the length of either of the other sides. So that tells me that I don't have enough information to solve the problem on its own. Okay, what I do need in order to work back, so let's pretend that I'm ready to work out x. What I'm telling myself is I need to either work out this side here or this side here. And if I know either of those numbers, I can work out x. The question is, which side could I work out from other information? Okay, well, quite clearly the side here doesn't look like it's attached to anything. We've got no other way of working out the hypotenuse. So we kind of have to discount that, which must mean we can work out something about this height here. So let's look at the triangle that's on the right hand side and see if that is going to help us. So we've got this triangle here on the right hand side. Is that going to help us? Well, we've got an angle, a number angle, and we've got a number side, which means that we can work out another side. We've got two bits of information. We can work out a third one. So we could work out this side here at the bottom. Is that of any use to us? We could work out that one, but that's not much use. The whole point is that we could work out this one as well. So in other words, we're kind of working out what can we calculate and what do we need to calculate and find out kind of common ground there. So it seems to me the first thing I'm going to do is to use the yellow triangle to work out the height, and then I'm going to use that information because the height is the same for both triangles. We can then copy that information into the second. So again, it might help you if you actually copy the two triangles down a kind of rough sketch separately, and just then see if that helps. Sometimes it does. So I'm going to do this. That's a wee sketch of the left-hand triangle, and I'm going to leave a bit of a gap, and I'm going to draw the right-hand one. Okay, so we've got right angles to mark in. We got right angle up here. There's one down here, and we're told that's 8 centimeters, and that's 8. That's the one we're wanting. And in this triangle, we've got 71 degrees. And we've got 12 centimeters. Okay, so in other words, this line here, the height is the common line. If we know the number on one side, we can copy it straight into the other. So in other words, in this problem here, this is my unknown side x that I'm going to go for. In fact, let's not call it x because the angle is as well. Let's call it y. Okay, I'm going to call this y. So we're on to just a right angle triangle. So this is a bit more familiar ground. There's hypotenuse, there's the angle up there, so the opposite's down here, and this is the adjacent. Okay. If I'm using SOHCAHTOA, then I can tick the hypotenuse, h, and I can tick y on the adjacent, so I'll tick A for adjacent. My two ticks are on CK, which means it's going to be cos. So cos x equals adjacent over hypotenuse. Okay, substitute in. X is the angle is 71 degrees, adjacent is y, and hypotenuse is 12. We can get rid of the 12 on the bottom of the fraction by multiplying both sides by 12. And so we've got 12 times cos 71 equals y. They cancel out. So y, according to my calculator, 12 times the cos of 71 is 3.906. 3.906, yeah. 906, which rounds to 3.9 if I'm doing it to one decimal place. centimetres. So here we've got y is actually 3.9 centimetres, which means that this is 3.9 centimetres as well. It's the same line. And now, what I've done is I'm going to bring this all over here. I've now got just a right angled triangle with two sides trying to work out x. So the actual, I'm using two kind of basic trig triangle problems, but until you see that, it's difficult to do. So the first challenge is to break the shape up into right angled triangles and work out a route to the solution. Okay, so just quickly then to finish this off, I'm going to label my sides. Hypotenuse, opposite, and adjacent. I'm going to write down SOHCAHTOA. I'm going to tick the sides. So what have I got? I've got 8 on the opposite, O for opposite. I've got 3.9 on the adjacent, A for adjacent. 2 ticks on TOA. So that's tan x equals opposite over adjacent. Substitute in x, the angle we don't have, that's what we're trying to work out. The opposite is 8 and the adjacent is 3.9. And of course, working out an angle, we need to know both the numbers. 8 divided by 3.9 on my calculator is 2.05. Now remember, it's a trig ratio, so we need to do it at least 3 decimal places. 2.051. Okay, x is the inverse tan. That's your wee shift tan. And if you do that on your calculator, shift tan 2.051, we get 64.00 degrees. So x is 64 degrees. Okay, it says calculate the size of the angle marked x. So we've actually answered the question here. X equals 64 degrees. Okay, so in both of these questions, it wasn't immediately evident how to work out the problem, and that's because both of them took more than one calculation. You have to be able to accept the fact that it might take you 2 or 3 trig calculations, but you might also bring in other geometry facts, Pythagoras' theorem, just other facts that you might need in order to solve the problem. So it takes a little bit of time. You start down a road, if you get stuck, you just come back to the start and try something again. Okay, it's about patience and resilience in it all. So hope that's helpful. You can go and practice some now.